Okay, so just some quick kind of housekeeping-y stuff. Thank you everybody for joining. I'm Corinne Wallach, and I'm helping with a lot of like the community and developer experience-y stuff with like the Apache Pinot folks. Today we are going to watch Chinmay Soman do a great presentation on Intro to Apache Pinot. It is going to be very welcoming to anybody who's like super early. And if you have any questions, and don't hesitate to ask, even if they feel super green, because this is definitely like an intro level kind of webinar, but he will be digging into a bunch of different things. I'll let him explain what the agenda kind of looks like. So just a couple things. Obviously, you can chat in chat room or chat in the chat. We do have some folks here that are heavily contributing, like PMCs and contributors for the Apache Pinot project. So they'll be able to answer a lot of questions in the chat, and we can also do a Q&A afterwards too. So if there's questions that like require a little bit more further explanations, we can do a kind of Q&A at the end of the presentation. Also, if you are not already, we welcome you to join the Pinot Slack. I posted 2 links in the chat. One is for the Pinot, just like landing page website thing. And then the other one is for the Slack. You can go either way to get to the Slack invite. Also, if you happen to see this presentation and you're like, this is so cool, I love Pinot so much, please give us a cool star on GitHub, because it makes us feel very happy. And it makes the contributors want to contribute more. So we got to keep doing that. And also, if you are watching this video, so we are going to be recording this video, we will publish it online. And if you happen to be watching it on YouTube, please like it. And you can also subscribe to the Apache Pinot YouTube, which we will be continuously publishing more content. It's still fairly new, but that's the YouTube link. So I've posted a bunch of things as I'm talking. And yeah, I think that basically covers the basic housekeeping. And I will introduce Chinmay now.
Hey all, this is Chinmay.
Oh, I was going to introduce you. I'll introduce you.
Oh, okay. Go ahead.
It's a little bit more of a fancier entrance. Okay, so Chinmay currently works as an engineer at a stealth startup company. Previously, he led the streaming platform team at Uber for building a large-scale self-serve platform around messaging, stream processing, and OLAP technologies. And before that, he worked at LinkedIn and IBM, focusing on distributed systems and security. He's a PMC and member of the Apache Samza, and also part of the other open source projects, including Pinot, Replicator, and Athena X. So just for some background, him and a few other folks, like some early contributors of Pinot, are working on some cool technology around Pinot. So if you see this presentation and you are interested in using Pinot and you need some help like running Pinot or setting it up, feel free to reach out to us. You can reach out to me, you can reach out to Chinmay, or you can also reach out to Uday. He's also in the chat here. Uday, hi, say hi. And that's it, Chinmay, I'll let you take it away.
Awesome. Thanks so much for the intro. Yeah, so today I'll be talking about all things related to Apache Pinot, starting with the use cases that Pinot is commonly used for. I'll give a high-level overview of Pinot for those who haven't heard of it at all. We'll also go through the architecture deep dive, look at all the different components of Pinot, how they interact with each other, and also look at the data layout, indexing strategies, and so on. And finally, we'll go through a quick demo where I'll show how to onboard a new table and query data within Pinot. So hopefully this should be interesting for all of you. So let's just jump right in. When we talk about real-time analytics, there's actually many different types of use cases that fall under this banner. The most important real-time analytical use case is actually what we call as user-facing analytics. So this is where you're exposing your analytical capabilities directly to your end users. So one of the best examples is, yeah, and by the way, if other people can mute,
Oh,
I'll
I
be
think there's a, is there somebody off of mute? Yeah, we have to, okay, I'm muting, hold on, I'm muting some people that were, sorry about that. Okay, I think we're all good now. There was somebody's phone was on. All right.
So yeah, one of the best examples of user-facing analytics is LinkedIn. It has a bunch of these products. One of them, as most of you might know this, is who viewed my profile. So whenever you visit this feature, it's going to show you a week-by-week statistics of the profile views for yourself. Another example is the LinkedIn feed ranking. So whenever you visit the LinkedIn homepage, uh, the feed ranking algorithm kicks in to make sure you're not seeing the same thing again and again. In other words, for any given story or content, we want to know how many times has a given user seen it in the last 14 days or so, which looks something like this. So it seems like a simple aggregation with some filters and group by. So seems straightforward, but the performance requirements of a query like this is quite severe. For one, it has to execute against the entire user database of LinkedIn, which is 700 million plus at this point. Also, for all active LinkedIn users, whenever they visit the homepage, this query is going to fire, which translates to multiple thousands of QPS, queries per second. And each such query has to execute very quickly, almost in real time. In this case, it's like the requirement is less than 100 millisecond P99. Otherwise, it's going to be a terrible experience for the users. Another example is from Uber, surprise, surprise. So Uber Eats actually has a product called Restaurant Manager, which is given to all the owners of the restaurants that are delivering with Uber. So when they open this tool, they see a dashboard, something like this. It's showing you the sales statistics across a wide time range, and also showing things like missed orders or inaccurate orders that need immediate attention and so on. Similar to before, the queries themselves seem straightforward, but in terms of performance, we are again looking at 500,000 users, the restaurant owners, the restaurants themselves. We have multiple hundreds of QPS, and again, each one has to execute very quickly. So both these are examples of analytical queries that are very high throughput, low latency in nature, and are user facing in general. Another category is business metrics and the ability to detect anomalies in real time. So for example, it's very important to know when, for example, in case of LinkedIn, you want to know if the page views suddenly drop at a given point in time. Or if you're Uber, you want to know if the demand and supply ratios are suddenly off for a given region. So you can imagine these are the business metrics plotted, and you can figure out the anomalies on a threshold. But what's more important is the ability to do a drill down across different dimensions to figure out exactly what happened. And this is what we call as root cause analysis. And both of these it's great to have them real time in nature. And finally, we have the dashboards, which I guess everyone is familiar with in one way or the other. You want to plot all your business metrics, charts, and graphs all in one area for your internal operators or SREs to monitor. And again, each dashboard can execute a complex query, and it's ideal to have them return very quickly. So these are just some of the categories of real-time analytics, and there's more. But if you step back, you start seeing some trends. All of these use cases are interested in analyzing the recent data at a fine granularity. So you want to look at every single event which has been generated in the last few seconds or minutes. They're also interested in looking at an aggregate view of the historical data. So the sum or count of things over the last week or months, that's also of interest. And again, both these things, the query latency is expected to be low. That's one of the key themes of all these use cases. Um, and if you look at the evolution of how analytics generally evolves in these companies, pretty much everyone starts with basic monitoring. So these are the dashboards that we saw earlier. You have the internal operators. For example, Uber has lots of city ops in every single region in the world, or even SREs that look at these dashboards. And then you have data scientists, PMs, and executives that want in on the action and want to understand, derive insights from real-time data, be able to triage events that just happen. So both these are sort of internal analytical use cases within the company. And then some companies like Uber and LinkedIn have started to monetize this capability. So through, as you saw in LinkedIn and Uber's case, they're actually giving this directly in the hands of the external users, and getting a lot of value for their users. So it's worthwhile to note that a lot of companies are already doing this today, but they may choose to use different technologies for implementing each of these use cases. Uh, if so, we think all of this can actually be done by one core technology, which is Apache Pinot. So for those who haven't heard Apache Pinot at all, it is a distributed system. It's a distributed columnar database that can ingest data from a wide variety of sources. For example, Kafka or S3, or you have GCS and so on, or TFS, and make all this data available to do analytical queries in real time. So you can have all your data ingested in Pinot and build all kinds of user-facing or internal products on top of Pinot. It is a mature system at this point. It's being used in a lot of big data companies across the globe. We're looking at 30 plus, 35 plus companies using this in production. And we're also growing pretty big on the community side. We're almost at 900 now. And in terms of scale, Pinot clusters are known to handle a large scale of production use cases. Some of the largest numbers are here. The largest Pinot cluster can handle upwards of 1 million events per second, can easily handle multiple hundreds of thousands of queries per second, while still maintaining a low query latency. So the SLA guarantees are achieved in even on the largest clusters. So at this point, let me talk about the internals of Pinot and how it achieves all these things. So as I mentioned before, Pinot can ingest data from a lot of different sources. So you have Kafka or Kinesis as a real-time source where you're getting one event at a time. You can also get the data from an offline source such as HDFS and S3. And what's cool is Pinot can ingest data from both real-time and offline for the same table. So it consolidates both real-time and offline data and provides one logical view to the user. The other thing that you can do is also have your OLTP data. So if you have, using MySQL or Cassandra, you can have the CDC or the changelog stream come out of those databases and also ingest it into Pinot through Kafka or HDFS. And so once the data is in Pinot, you can build all these different products as you saw before. So let's look at how Pinot organizes data internally. So it will take both the real-time and offline data and distribute it across a bunch of servers in the cluster. It uses something known as a controller to decide what data goes where, how the data is replicated and partitioned, and it uses Zookeeper to maintain all of this state. And finally, it uses something known as a broker to support the user queries. So whenever any of these products send a queries to the broker, it will look up the state from Zookeeper and do a distributed scatter gather to process the query. So let me give you one scenario to explain this in a little bit more detail. So let's take a real example. We have a Kafka topic with 4 partitions as shown by the different colors here, and we have 4 servers, and then we want to ingest a real-time table into Pinot. So the very first thing the Pinot controller will do is look at the Kafka topic and identify there are 4 partitions. And for each of these partitions, it will assign a segment for ingesting data from that partition. The segment here is a unit of data partitioning and replication, and I'll talk about it in the next slide or so. So in this case, not only has it assigned segments, it also assigns the segments to different servers as shown here. And this is what we call as routing information. Once this metadata is created in Zookeeper, the different servers will actually start ingesting data from the respective Kafka partition and create a local segment on any of those servers. Now, with any good distributed system, you want to make sure data is replicated. So let's go ahead and do that. Let's configure this table to have a replication factor of 2. So with that information, the controller will actually assign the segment to 2 unique servers for each such segment. And again, the servers will get once the metadata is updated, they will be triggered and start replicating the data and creating local segments. So at this point, the data is flowing from Kafka to all these servers, and then they're just getting stored as a local segment on the local disk. Now, when the Pinot broker gets a query, something like this, it will look up the routing information and know which servers I need to communicate with to process this query. So essentially what it does is it passes down the query to each such server. Each server in turn will take that query and execute it for the local segments that it has and return an intermediate result to the broker. And then the broker will do a final aggregation and return the response back to the user. So this is for a real-time Pinot table. Things work slightly differently for the offline table. So let's imagine instead of Kafka, you have your raw data sitting somewhere, maybe in HDFS or S3. We can run a process to convert this raw data into Pinot segments and store it in a well-known location known as a segment store. And you can use standard frameworks like Apache, like the Apache Spark and Flink. And these frameworks, once the segments are generated, will notify the Pinot controller about the location of these generated segments. And then the Pinot controller will do similar things. It will update the metadata, and the servers will fetch the segments and copy it locally from the segment store. One thing to note is recently we have added the ability to import this data natively within Pinot. So we have a background task which will do all of this and automatically import the data into Pinot. And so the other good point to note here is you can have both real-time and offline flows set up for the same table. So within Pinot, you'll have different servers doing real-time and offline segments, but from a user perspective, they will not really see the difference. For them, it shows as one logical view, and they can query both real-time and offline data sets as one table. And in general, this is a great design for a distributed system, because you have, if any at any point of time you're running out of capacity, all you do is you simply add more servers. The controller will identify these servers and start creating new segments onto those servers. So it's very easy to scale in terms of capacity as well as in terms of performance. So as promised, let's look at the Pinot segment in a little bit more detail. This is really the secret sauce behind Pinot's low latency performance. So let's assume on the left we have some raw data, which we need to convert into a Pinot segment. So internally, the way Pinot lays out data is in a columnar format. So it'll take each of these columns and align it together in a contiguous manner. So as you can see, whenever you get a query like this, you need to do a count star where country is US. It can easily satisfy this by just scanning this one column, which is the country column. So just using the columnar format, we can already speed up the query execution as compared to the scans on the raw data. So this is great. But what the unique thing about Pinot is the ability to support all kinds of indexes on any of these columns. So for example, you can specify an inverted index on any of these columns. So in this case, we are defining an inverted index on the country column. So for executing this query, now I only need to look up the entry corresponding to US. And you can imagine the execution is much faster. Similarly, you can add a sorted index, which uses a form of run length encoding. And this is even faster. In some cases, it's even faster than the inverted index. And there's another example. This is the most powerful index that Pinot has. It is known as the star tree index. So the star tree index allows you to maintain pre-aggregated values for certain combination of dimensions. So in this case, we are defining the dimensions of the country and the browser. And for executing this one query, all you need to do is a lookup of one single value, essentially. So this, with the star tree index defined, your performance of your query is real time in nature. It almost seems like an OLTP database at that point. So it allows like millisecond level query latency. So you can define all kinds of indexes on top of any of these columns. We constantly keep adding more and more types. For example, at this point, we have JSON indexes, geospatial indexing, we have Bloom filters and text search indexes and so on. And one thing to note is this can be defined at any point of time. You do not have to do all the data modeling before creating the table. You can always do it after, and those indexes will kick in even for your older segments. In terms of the, Pinot uses different techniques at different points of the query execution, and it has a support for different types of, for example, data representation. You have the columnar storage, you can have the bit packing, you can also have the star tree pre-aggregation as a storage footprint. We can define different kinds of indexing strategies for the filter phase of your query, and similar things for the post filter. So when Pinot gets a query, it will intelligently decide how to mix and match these different strategies to get low latency for your queries. So at this point, let me actually switch to the demo. Let me actually share my entire screen.
We do have some questions too. Do you want to do the demo now and then ask the questions after? Or
we can, yeah, while I set up, maybe we can answer some questions.
All right, while you set up, that's good. Okay, so I'm just going to start at the beginning. So any insights on the cost for Pinot in terms of ingest and query rate? Say we are ingesting about 1 million events per second, each about 1 KB in size. What would the cost of a cluster be able to handle 1,000 queries per second, each scanning about 10 million records? That might be a good question for Uday.
You want me to stop sharing?
Yeah, we can answer, if we can answer these questions quickly.
Okay, so let me understand this.
Oh, Will answered some, he did respond with a question, but go ahead.
Okay. Yeah, so I mean, as I mentioned before, the cost of a cluster will come from a couple of different points, right? One is the total data that you need to manage. With columnar compression, you're getting a lot of compression on your data. So typically, it can be the data footprint can be reduced by like 50% to or even like 20%, depending on the data. So with columnar format itself and the bit packing and the different storage strategies that we use, you already reduce on the total footprint. In addition, with all the other thing to keep in mind is for your query performance, you need to have enough parallelism in your cluster. Right? So it's a combination of what indexing are you using, and how much do you want to do the scatter gather. Right? So I can't give you an exact answer there, but you'll have to play around with all these different strategies. In my experience, the cost of Pinot, like serving something like this on Pinot versus other options, Pinot was definitely more efficient in terms of the on-disk and in-memory footprint, and needed a smaller cluster.
Cool. Next question. Hopefully that answers the question. If it doesn't, we can definitely elaborate more at the end if you have additional questions. So we have 3 more. So let's just try to, like, if we can.
Let's cap it at 3 more and then we'll switch to the demo.
Yeah. So is the data flow down if Zookeeper is down?
No. So once there are some things that, like, once the Pinot servers are ingesting data, that'll continue to happen. However, at some point when we need to create new segments, that's not going to be possible if the Zookeeper is down. Also, it'll create issues on the query side as well.
Okay, cool. From an operational perspective, is it typical or is it logical to separate real-time and offline servers?
Yeah, good question. So the thing to note here is the performance characteristics of real-time and offline servers are different. In case of real-time servers, when it's consuming data from something like Kafka, it is keeping things. Some of the stuff is actually in the Java heap, and we do have the ability to offload a lot of it to off-heap memory. But that's the key distinction. So we want to have a different server profile for the real-time server and a different profile for the offline server.
Nice.
Okay, so how about we switch
one
to the
more? Oh, did you?
Okay, go ahead. We'll do one last
more question. This is the last one from the 4. So does it support an open columnar format like Parquet or a closed format?
Right. Yeah, great question. So right now it is a closed format. But there are talks to also support things like Parquet, at least from a data ingestion point of view. Okay.
Okay. Yeah, I think we're good. We can continue. Thank you.
Sure. So in this demo, I'll walk through. So what we're going to do here. So this is actually part of our documentation. So if you're new to Pinot, I highly recommend playing with this on your own. What in this demo, what we'll do here is set up a Pinot cluster. So it'll actually bring up all the components like Zookeeper, controller, brokers, and servers. It'll internally also create a Kafka cluster and start publishing data from the GitHub Events API. Specifically, we are interested in the PR merge events, which is published into Kafka and will be ingested into Pinot as a real-time table. So can you see my the terminal?
Yes, we see it. If anybody needs anything, I mean, I think we could see the text, something that's better.
Okay.
Good.
So in the same in this page, you'll see there's a long version and short version. For sake of time, I'm just going to use a shorter version here. And it's going to go and start setting up Pinot, Kafka. So this page will actually describe all the things it's going to do. So this is a one-click demo. It sort of brings everything ready for you to play around with. So you'll actually get a working Pinot cluster with data already. I think there's some echo. Okay.
Yeah, I got it. I turned that person off. Taking away your microphone privileges.
Okay. So once this, at some point, your Pinot server will start, and then you can go to this URL, localhost 9000, to see the Pinot UI. Right. Here you can look at different components of Pinot. We have one controller, one server, and one broker for sake of this demo. Okay, and then right now it's showing 0 tables because it's still working in the background. Let's actually take a look. Right, so we have now it has actually created a table already, and for each Pinot table, we have a corresponding schema which defines what's in that table. Right? So let's take a look at this particular example from GitHub. So this is a predefined schema which comes as part of that demo. We have it defines a bunch of dimension values, dimension columns. We have like title, author association, committers, and so on. These are the dimensions which you will do slicing and dicing on. So a lot of the filters can be applied directly on these dimensions. And then you also have the metrics to keep track of the aggregation numbers for your schema. And then the other thing the schema also defines is a time column. So in this particular case, we have the merge time millis as a time column, and the granularity is in terms of epoch, milliseconds since some starting time. So this schema has been created specifically for the GitHub Events API, and for any such for your data source, you can create a similar schema like this. And let's also look at the table that was already created for you. So here you can see other properties of the table, such as how much retention do you want on your table, what is the replication factor, and also the indexing configuration. So in this case, the table predefines some inverted index on these 2 columns, which is organization and repo. So any filter queries on this is bound to be faster than like ROS. And you also have the ingestion related properties. In this case, we are, as I mentioned, we have an internal Kafka cluster. So it's pointing to that. From this topic. Lastly, it also shows you the segments that belong to this table. So right now, both these segments are hosted on the one server. We only have one server. And we can now start playing with the data that we already have. So you can see the schema on your left and do all kinds of queries here. For example, let's do a count star. So you have 19 rows ingested so far. And this is actually, it's happening in real time. So these are the merge events that's happening on GitHub, and we are capturing it within Pinot. So as you can see, the count will actually keep increasing. Right? And then you can do, you can play around with whatever you want. So this is cool, but now what we want to do is add an offline component to this table. So let me remind what we did so far. We are actually have a real-time stream from GitHub that's going into Pinot, um, and you can do any sorts of queries on it. But what's cool is, let's say you have some historical data for the same event source. So in this case, it's I have something like this, which was captured from a few days ago, right? And this is typical with a lot of use cases. You'll have, for the same data source, you'll have a real-time source and historical data somewhere in HDFS or S3. So what we want to do is now add an offline table for an offline component to the same table with this data in mind. So let's do that. The first thing I'm going to do is create the offline table, which looks something like this. Right? So we have the same table name as the real-time table. And then there are some other properties that I'm defining for the offline table. And this is the simplest sort of table config. We're not really adding anything more complicated here. As I mentioned before, you can always change this at runtime, even after the table is created. You can always create new indexes as you wish. Okay, so let's go ahead and create the table. So this will simply create the metadata for that table in the cluster UI. So now you can see there is, for the same table name, there are two components. There's a real-time component, which was pre-built in this demo, and there's an offline component, which we created just now. So it's the same table config, and you can note that it's also using the same schema as your real-time component. So this is what sort of ties in the real-time and offline tables together, the same schema. And of course, there is no data today since we haven't really pushed anything so far. So let's go ahead and do that. What we'll do now is I have the JSON data somewhere in a file locally. I'm going to run this command. This is the import data command that was recently added. It'll actually take the raw data, generate Pinot segments, and push it to your Pinot cluster. Right? And this can be, again, this is just a demo, but this can be done as part of your production Pinot cluster as a background task, which runs natively in Pinot. You could also choose to run your own frameworks like Flink and Spark to do this and push the data again to Pinot. So now, as you can see, the data is actually in Pinot. And let's try to now query all this data. So if you note here, we only have one table. It's the same table name. But underneath, it's actually querying both the real-time and offline components. So suddenly you see a lot of rows. And this is clearly not from the real-time. It's getting from both the data sources. And then you can let's just play around with some queries just to show, typically what you can do. You can do a group by on the author, on the association. So here we are categorizing the count by the type of author. You could also do simple filters. For example, let's see, so num lines added is greater than 1,000, for example, and maybe num committers is more than 1, and then same group by query. Right. So you can imagine you can play around with any sort of queries. As you can see, the time used here is small. Although I have the data set itself is not big, but you can add any kind of indexing on these dimensions to make it even faster. So let's go back to, so this is, in this way, you can have like a hybrid table of both real time and offline, and the users really don't know what's happening underneath. They see one logical view for query. As I mentioned before, the performance of your queries will be impacted a lot by the choice of indexes that you define on your table. So these are some of the stats from not from this demo, but from a larger use case that we analyzed. So this is a simple aggregation with filter query. The raw scan, as you can see here, is taking almost 2.5 seconds. And the performance drastically improves with different strategies that we have added here. So with the Bloom filter, it becomes like almost like a 1 second down to 1 second. And with sorted and inverted indexes, we're down to like millisecond level granularity. This is another type. Pinot also supports a range index. So if you have select count star where the time is greater than some time in the past, those kind of things in a raw scan will take a lot of time. As you can see, 40 seconds here, whereas with the range index, it's much lower. Similar thing with a text index. You can do things like regex like filter queries, and with the text index will give you real-time latencies in that case. And finally, we have the start index, which is even faster than things like inverted index. As I mentioned before, start tree will actually have pre-materialization of some combination of dimensions. So it's almost like a lookup of values. But the cool thing is it doesn't really, there's a way to control the right amplification even with the start tree index. So you don't explode your data footprint even with something like start tree. So Pinot has a lot of these different kinds of indexes. And I think this is a simple comparison with Pinot and the other common technologies that are used for such use cases. And I think where Pinot shines is things like start tree index, the geo index, which was added recently, same thing with JSON index and so on. The whole point of Pinot is the pluggability aspect of it. So you can keep adding these different kinds of strategies and apply them to your existing data sets, which will speed up your queries without having to re-bootstrap all your data. So I'll stop here and maybe you can take more questions. But before we go, if you're interested to learn more, this is again a high-level intro. I'm sure there are more questions. Please join our Slack channel. I've sent the link. I've given the link here, and I'll share the deck after this. And you can find us on Twitter at Apache Pinot. I'm sure Karine has more to share in that regard.
Yeah, I can share. I also just posted in the chat if anybody has any other questions, because it's kind of hard to keep up with what questions have been answered and what hasn't. Because I see there were some questions about the server going down, like what happens to the data and how, some things about like backup and restore strategies and things like that. But it looks like it's been answered. And what happens if the offline table is unavailable or the queries slow down? I think that one might have been addressed too. But I put it out there. If anybody has any questions now that you want to ask Chinmay, you can just post them in the chat now, and then we can ask him directly. That works. Chinmay, great presentation.
Thank you.
Okay, I'm going to post in the channel too, in the chat, while everybody is hopefully writing their questions. Like you can prepare your questions now. Sometimes it takes a minute to write it out. So while we're waiting, okay. What is the query language and query limitations?
Yeah. So as of now, we are supporting the calcite query semantics. We used to have a proprietary one, but we're now switching to like full SQL. There's another dimension to this, right? So Pinot natively supports the calcite query. The other thing that companies are also doing is to have things like Presto on top. So you can, there's a Presto Pinot integration that we contribute. And you can do all kinds of complicated Presto queries. And the connector does an intelligent job of pushing down a lot of the filters, filter predicates, and aggregation queries. So it's much faster than traditional Presto. Um, and on top, it also gives you the flexibility to do things like joins, all kinds of UDFs that you want to apply on top of Presto and so on. But the native Pinot does support calculating.
Cool. We do have a couple other questions that came in that are really good. So we have any recommended backup or restore strategies?
Yeah. Okay. So let me.
And then we have like 3 more that just came in that are really good.
Sure. Let me share the screen again because this is important.
Mm-hmm.
Yeah, great question.
Cool.
So let's go back to the data flow. What I mentioned here is, as I mentioned before, Pinot will get the data either from Kafka or from a secondary storage and store it locally. But what it also does is persist all those segments, the segments that are already built, into something known as a segment store. Right? This is just another name for an additional storage that you have outside of Pinot. And this could be whatever you want. This could be a simple NFS filer. It could be HDFS or S3 or GCS. You just configure it as part of your Pinot cluster setup. And Pinot will automatically archive the built segments into your segment store. So at any point, if a server goes down, for example, we have a hard disk crash and we need to rebuild the server, all it needs to do, we spin up a new node, a new machine. It joins the cluster and it automatically downloads the segments from this segment store. So this sort of works as a backup strategy as well. It also works great when you need to do cluster expansion and you need to migrate stuff from one server to another. You can also directly copy from the segment store.
Awesome.
Was there another part to that question?
There isn't another part to that question, unless the person who asked it. I can't remember who was who. If they have more, they can definitely elaborate, and we can touch base on it again. Okay, so Krishna asked, could we replace the typical Spark streaming or Flink like calculation with Pinot? And then he said, I mean, just streaming and no offline table use case.
Yeah, you can. So for example, you can, if what you're doing as part of your Spark streaming or Flink is to pre-compute some values. So for example, you have a bunch of dimensions and you're computing a metric on across those dimensions. You don't really need a Flink or Spark job. You can directly ingest the raw data into Pinot and do these queries on the fly with something like star tree index. So it can, with the star tree index, it can handle all that throughput and low query latency. So it sort of, the need to pre-compute is gone with this strategy. And that's typically why people would use Spark or Flink in the first place.
Cool.
But one thing to note is for complex things, for example, if you want to do joins before the data is ingested into Pinot, for example, you have OLTP streams coming from different tables from MySQL, and you want to normalize the data, denormalize the data into one schema. That join has to be performed in something like Spark or Flink, and then you can ingest the resulting stream into Pinot.
Cool. Are messaging platforms like RabbitMQ, ActiveMQ supported as a source?
Yeah, I mean, it's, as I said, Pinot is pluggable, so it's easy to add a new source. At this point, we're working on the Kinesis support, which will be out soon. I don't believe we have those two specifically yet, but it's easy to add it as a source.
Cool. If anybody else has any other questions for Chinmay, now is your chance to ask. It's not your only chance forever, but it is your chance to ask. Um, and also just a reminder too, like while we're waiting for people to probably ask their questions, just a reminder that that there are some folks from the Pinot contributing team, the founding contributing team. I don't know exactly what the authors that are building some cool technology around Pinot. And if you need any help running Pinot or setting it up, you can either reach out to Uday, to Chinmay, to me. Here's Uday's email address if you want to just contact him directly. But he also is here, and he's also on the Pinot user Slack. Okay, somebody asks, Bauman asked, what is the resource impact of using Pinot storage and compute?
I'm not sure I understand. Can you clarify what you mean? Do you mean how much CPU memory we need for each of these? I'm not sure I understand the question.
Okay, we'll give him a moment to elaborate. So Krishna, we will be publishing this YouTube link online. I think we can also probably put the slides up on SlideShare or something.
Right. Yeah, I think he clarified the question. How much extra storage do we need? Yeah, so so when Pinot does need a local copy of the segments today to execute queries. So essentially, you'll need to size your Pinot cluster based on the data footprint. And by data footprint, I mean the derived data footprint, not the raw data footprint. So it will keep archiving segments in deep store, but today it needs a local copy to process the queries. We are adding a feature to do lazy loading of segments from the deep store. So it doesn't necessarily need all the data locally, right? When that feature comes in, at that point, we may not need as big a local storage as we do today.
Cool. Thank you. Hopefully that answers. Also, iPhone asked, how would you do querying when the cardinality of data is very high?
Yeah, this is obviously, when you do need to figure out the right indexing strategy for for a given use case. It is going to be, if it is very, very expensive, there are some strategies that even simple indexing may not solve. For example, LinkedIn has a bunch of use cases where one of the query dimensions is member ID, and then the cardinality is obviously very high. What Pinot provides is the ability to partition your data on this very high cardinality column, and that partitioning works hand in hand with the other indexing strategies. So intuitively, what that means is you prune the number of segments or the number of servers that you need to query using this partitioning. And then each of those servers will use the local indexes to process the query. So there is a way to handle even high cardinality columns in Pinot. I think Kishore mentioned the same thing.
Yes. Can you throw some light on API SDK?
Yeah, so I mean, we can share it along with the slides, but a lot of that documentation is available online on docs.pinot.apache.org. This is a great resource for you to have for knowing not just high level, but also like low level details of Pinot. So here's a simple broker query API for you. So you do have an API access, RESTful API for issuing queries. For more advanced users, there's also a controller API that you can use to manage your cluster and your tables.
Okay. Is there a JBDC driver or equivalent?
Yes, there is support. There is already work happening in that regard. We do have JDBC support on top of Pinot. There will be a blog out soon to explain this in more detail. We are working to add finishing touches on in this regard, so it will be out soon.
And also, Well, Mike asked, I was thinking maybe somebody from our team would answer this. Is there a link to track the lazy loading feature?
Yeah, there is one issue. If someone can look it up, um, or maybe I can look it up while this other.
Ah. You're becoming Google. It's great.
There you go.
Cool. There you go. Nice. Thank you. Mike is laughing.
Your
Yeah. Does anybody have any other questions? Okay. All right. I feel like I like need glasses. Every time I'm like looking at the questions, I'm like, I think we are a little bit over the hour, but I don't know if you have a hard stop, Chinmay, or do you want to answer the question?
I mean, I don't know if people want. I can stay on for a little bit longer for sure.
Okay, we'll do another couple minutes. Adding executors dynamically.
Auto scaling. Yes.
Yeah. Oh, auto scaling.
Yeah. So Pinot does have. So first of all, there is, a way to deploy using Docker and Kubernetes and all that. Then there is a way to do auto scaling as well. I can once we have maybe a good documentation on that, I'll be happy to share. Not sure if Xiang is on the line. If you want to share some docs.
Xiang's probably.
He's on.
I am. So basically, yeah, basically when we deploy Pinot in Kubernetes, there's a way of handling that, and we'll publish some documentation on that area. Basically, it's like we can deploy more Pinot servers. You can scale Pinot server instances, for example, double the instance size, and then you can actually do a rebalancing on all your data, and then basically it's like redistribute all your data.
Cool. That was awesome and convenient that he just popped up. We have the primitives to auto scale, but there's no component that monitors the metrics and automatically auto scales.
Yeah, it has to be done out of band right now. There's obviously API to do it, but there's no integration.
Okay, cool. I'm gonna give people 1 more minute to write other question really, really, really fast. And if not, then we can wrap up. And Chinmay and the team are also available on the Slack. I know I posted this like probably 4 times already, but I'll post it again just so it's on the top of everybody's.
Yeah, the Slack is pretty active. Not just the contributors, but like people like Ken and other folks really active. And it's a great resource to have to learn more or just discuss your specific use case in detail.
Neha said, great session, Chinmay. And also just like really quick before because we do have another question, but really quick, just if you guys liked this presentation and you like, well, if you like the presentation and you're watching it on YouTube, give it a thumbs up. But if you like Pinot and you think it sounds really cool, feel free to give us a star on GitHub and make the contributors feel happy. And you can also subscribe to the YouTube and follow on Twitter. Krishna asked, Krishna has a lot of questions, really digging deep here, just digging. It's great questions though. Chinmay loves good questions. Is the segment store basically a storage or a platform?
Yeah, I mean, think of it like an external storage. So as I mentioned, it could be anything. It could be NFS, HDFS, S3. You can add your own segment store. Pretty much everything in Pinot is pluggable and add a protocol to use it. So at this point, for example, Uber is using HDFS as the segment store. And there's companies in the cloud that are using S3 and GCS.
Cool. Awesome. Chinmay, great session.
Sure, no problem.
Yeah. Thank you so much for taking the time and
Thank you all for joining us.
for helping everyone learn. This Chinmay's side hobby as he becomes a technical trainer now. Thank you guys all for coming. Feel free to like ping us on Slack, or Slack is probably the best place to reach everyone. And if you guys have any other questions, please let us know. And also, like, if there's any like suggestions, my name's Corrine Wallach. I know it says Pinot, Apache Pinot on my username, but I'm also on the user Slack. So if you have any ideas on how we can improve the experience for developers like learning, please feel free to like share those thoughts with us too. Cool.
Awesome.
Yeah, thank you so much. And we'll see you guys all soon. There is other meetups coming up. One that's, well, it's probably a little bit more advanced, but you guys can please check out the meetup group. I think it's not in here. I didn't put it as one of my links because.
Once we share the deck, we can probably share out the link to the meetup, the
Yeah.
Pinot meetup.
Here, I'll put it right. I'll put it right now. I have it right here in the front. Yeah, so feel free to, join our other meetup sessions that we have coming up. This should be good ones. Cool. Thank
Awesome.
you.
Thank you all. Take care.
Bye.